Assalamualaikum and hi all. So today we are going to learn in chapter 6 and 7 about how to test the hypothesis for large sample. So if you remember in our previous lecture, we have decided and we have argued that the large sample should be greater than 30. So in this chapter, we are going to test the hypothesis for the large sample that is more than 30. So first of all, we are going to test the single mean and the single proportion. And the second one is we are going to learn on how to test the hypothesis for difference between two mean and the difference between two proportion. So this is the terms or the aspects that we are going to use when we want to test our hypothesis. So the first step, we must define or we must find what is the null hypothesis. So we have learned in our previous lesson in the chapter of Introduction to Hypothesis Testing, that is in chapter 5, we have to learn what is the hypothesis and what are the two types of hypothesis, that is null and alternative hypothesis. And we also have discussed about what is the significance value, that is the cut off point 0.01 and 0.05, that is the significant value. And also we have learned about what is type 1 and type 2 error. So now in this chapter, we are going to learn on how to calculate or how to test the hypothesis. So first of all, we must state it and we must find what is the null hypothesis. So null hypothesis is a hypothesis that is equal to 0 or no differences, that is contradict to the alternative hypothesis. So that is the first step. And the second step, we must show and state what is the alternative hypothesis. So alternative hypothesis is the hypothesis that usually the researcher wants to support because there is a significant findings. And the third step, we are going to test the statistic by using the specific or the appropriate formula based on the situation and based on the questions. And then we are also going to find what is the p value. All right. And then in our fourth steps, that is refer to the rejection region. So in this step, we are going to find what is the critical value, that is the Z value, and what is the significance level, that is 0.01 or 0.05. Remember, in our previous lesson, the significant level should be alpha or beta must be less than 0.01 or 0.05. Then if our alpha that is less than 0.01 or 0.05, then our result shows that there is a significant effect. So in this fourth step, we are going to find the critical value, that is the Z score. Critical value, the Z score, and the significance level, that is alpha. Either it is less than 0.01 or less than 0.05. Values that separate rejection and non-rejection of the null hypothesis. So in these steps, right, we are going also to see either our test statistic is in rejection region or in non-rejection region. So where is the area of rejection region? So if you see in this graph, right, the rejection region is in the shading area. So this is the shading area here at the right tail, and the left tail is where the rejection region area is occur. And in the center, that is the confidence interval, is the area of non-rejection area. So this is non-rejection area in the center. And the shading area here is the rejection area. Okay. So in our final step, we need to conclude our finding. So either we want to reject the null hypothesis, or we not reject the null hypothesis. And also we are going to state either what is the practical significance of our results. So this is if where the error and the statistical significance is occur. First, the significant level alpha is the probability if rejecting HO when it is in fact true. The p-value is the probability of observing a test statistic as extreme as or more than the one observed. Also, the smallest value of alpha for which HO can be rejected. When the p-value is less than the significant level alpha, the null hypothesis is rejected. This happens when the test statistics exceed the critical value. All right, what is the main point here? So it stated that the significance level of alpha, right, the p-value should be less than significant level alpha. That means if the p-value is less than 0.05 and 0.01, so we must reject the null hypothesis. All right. So when we reject the null hypothesis, then we are going to use the alternative hypothesis. Okay. So in a type 2 error, beta is the probability of accepting HO when it is in fact false, like we have discussed in our previous lesson. Okay. So you can refer in chapter 5 about type 1 and type 2 error. So the power of the test is 1 minus beta, the probability of rejecting HO when it is false. Okay, so the type 2 error is occur if the beta is the probability that is beta, the beta, we accept the HO when actually it is false. Okay, but the most important thing is to test the hypothesis is in this part. It means in the first, the second, and the third part. All right. So we are going to see some examples. So for large sample test statistic, so large sample test statistic that is referred to greater than 30, So we are using the Z distribution. We are going to use the Z distribution, the Z distribution. If, let's say, we have small sample size is less than 30. So to test our statistic, we are going to use the T distribution. Okay, for small sample size that is less than 30, so we are going to test our test statistic by using T distribution. Distribution. Okay, but for large sample size that is greater than 30, we are going to use the Z distribution. Okay, so in this chapter, we are going to use the Z distribution because we are going to use the large sample. Okay, so we are going to use the Z distribution. So to test one of four population parameters when the sample size are large, we are going to use these four parameters or these four formula. So the first one is the mu for the single mean. The second is the single proportion. The third is the difference between the two means. And the last one is the difference between the two proportion. Okay, so let's see the example. So this is stated that the Z distribution equal to statistic minus hypothesized value divided by standard error. Okay, never mind. We are going to see the examples. So example 1. The daily yield for chemical plant has averaged 880 tons for several years. The quality control manager wants to know if this average has changed. She randomly selects 50 days and records an average yield of 871 tons with a standard deviation of 21 tons. Right, as usual, we are going to recognize the key points in this question. So, in the first sentence, the daily yield for a chemical plant has averaged 880 tons for several years. So, average 880 tons. So, when it's stated or about average, the question wants you to find the average. So, average must refer to mean or mu. Okay. And then the quality control manager wants to know if this average has changed. If this average has changed. So if it's stated that if this average has changed, so it could be maybe the average of 880 tons will be less than or more than. Because it stated that the control manager wants to know if this average has changed. So this average, that means the average of the chemical plant of 880 is changed or not. Either it is less than 880 or greater than 880. Okay, now she randomly select 50 days. So randomly select 50 days is equal to the sample mean, the sample population. Okay, sorry. And records an average, okay, records an average of 871 tons. So an average yield of 871 tons is referred to the S bar. Because it talk about average with a standard deviation of 21 tons. So what is the key point here that we can highlight? So the first one is the mu. Mu is equal to 880, and the second one is n. Now n is equal to 50. And the average yield of 871 ton is X bar. So X bar is equal to 871. And standard deviation, that is S. So S equal to 21. So what is the first step? So the first step is we need to recognize and we need to state what is the null hypothesis and what is the alternative hypothesis. Okay. So the null hypothesis, that is HO, is mu equal to 880 tons. That is the mu here. Okay. So if null hypothesis, that is mu equal to 880, so the alternative hypothesis, that is HA, must be contrary to the null hypothesis. So HA is mu is not equal to 880. So you can state it, the hypothesis for null and alternative like this one, okay? Or because the question is stated that the control manager wants to know if this average has changed. So it can be less than and greater than. So you can also state it for your alternative hypothesis is HA is mu less than 880, or you can state it that mu is greater than 880. So that is the first step. And the second step is we are going to test the statistic. So based on these situations, so it refers to the single mean. So this is the formula for single mean. Right, so the value of x bar here is 871. So minus with mu 0. Mu 0 is new null hypothesis. So mu for null hypothesis is here, 880. So minus with 880. Divide by S is standard deviations that have been given here is 21. So divide by 21 and divide by square root of n. So n that has been given is 50. So insert the value of 50. Alright, to get the answer, when you calculate this answer, you will get z equal to negative 3.03. But first of all, right, this is important step also. You need to calculate the above value first. So that means you need to calculate the value of 871 minus 880. So this is the first step. So you are going to get the value is negative 9. And then the second step is you find the below value. So it is when you calculate 21 divide by square root of 50, then you will get the value is 2.96. Okay, then the final step, the third step, you are going to divide the value of negative 9 with the value of step 2, that is 2.969. So the final answer, you will get negative 3.03. This one. Okay, your final answer is negative 3.03. So your test statistic here is negative 3.03. So what are the next steps? So the next step, you need to find the critical value or the P value. Let's say you are using the critical value approach. So what is the critical value of Z that cut off exactly alpha divided by 2, that is 0.1 divided by 2 equal to 0.05 in the tail of the Z distribution? So the critical value that has been given is 0.01. But we need to divide by 2 because we want to know the both tail, that is the greater than 880 or less than 880. So that must be into tail or into region. So when you draw the graph, okay, so you will get the alpha value divided by 2, that is 0.05 for both tail. Okay, now because this is the large sample size that is greater than 30, then you must refer to the standard normal table. So when you refer to the standard normal table, you can find what is the Z value that approaching to the alpha value, that is 0.005. So when you check in a standard normal table, then you will get the Z value is negative 2.58 and 2.58. So you will get the value of negative 2.58 in standard normal table. When you refer the value of 0.005, what is the value that value of Z score that approaching to the value of 0.05. So you will get negative 2.58. So now we are going to see either we want to reject or not reject the value. Okay, we are going to reject HO if the Z value is greater than 2.5. That is here. If the Z value is greater than 2.5, because this is the rejection region. So we are going to reject the null hypothesis, our null hypothesis, if our Z value is greater than 2.58 or our Z value is less than 2.58. That is approaching to the left. So this is going to be the rejection area. So if the test statistic fall in the rejection region, so its p-value will be less than alpha equal to 0.01, because the significant value should be the p-value is less than 0.01 and 0.05. Okay, now if the statistic fall in the rejection region, so the p-value should be less than 0.01. Okay. So now, in our test statistic that we have test earlier, right? In our previous slide. Okay. So we have when we test the statistic, we get the Z value is negative 3.03. So negative 3.03 is something around here. Okay, something around here. If you see in the graph, so negative 3.03 is around here. Okay, so if it is around, this is negative 3.03. So if this negative 3.03 in this area, so it must be less than negative 2.58. So it is fall in the rejection area. So we must reject the null hypothesis at the 1% significant level. 1% significant level is this one that have been given. So what we are going to state in our final step or our fifth step. So we are going to say that the value, we are going to say that the 880 tones is going, the average of, we are going to state that, let's see in, okay, in this, okay. So in our fifth step, we are going to say that there is the sufficient data to support that the quality control, that the average of chemical plant has changed. Okay, it has changed either less than 880 or greater than 880. Okay. So let's say if we are going to use this one, if we are going to use the critical value approach, so we can also use the p-value approach. So how we are going to use the p-value approach to see either our test statistic is in rejection region or in non-rejection region. So we are going to use p-value p z greater than 3.03 plus p z less than negative 3.03. So p plus p, we are going to get 2p, and z less than negative 3.03. Okay, so this one we are going to refer to standard normal table. We're going to refer to standard normal table or the Z distribution table. So we are going to get 0.0012 times by 2, then we are going to get 0.024. So when you draw the graph, negative 3.03 is here, and 3.03 is here. So the value is 0.024. So 0.024 is actually less than the cut-off point 0.05, isn't it? And 0.01. So if the p-value is less than 0.05 and 0.01, so that means there is a significant finding or significant effect. If there is a significant effect, then we must reject the null hypothesis and accept the alternative hypothesis. So this is an unlikely occurrence which happens about 2 times in 1,000, assuming that mu equal to 880. So it stated that here that the mu, it is not possible that mu equal to 880 because we have rejected the null hypothesis. So we accept the alternative hypothesis that mu is not equal to 880, or the mu is less than 880, or the mu is greater than 880. Okay. So let's see the next example. Regardless of age, about 20% of American adults participate in fitness activities at least twice a week. A random sample of 100 adults over 40 years old found 15 who exercise at least twice a week. Is this evidence of a decline in participation after age 40? Use alpha equal to 0.05. So first of all, we need to recognize what is the key point in this question. So in our first sentence, it states that regardless of age, about 20% of American adults participate in fitness activities at least twice a week. So the value that have been given here is 20%. So P, or the proportion, is 20%. So the proportion is 20%. 20% is 20 divided by 100. So you will get 0.02. Sorry, you will get 2 decimal places. So 1, 2, because you divide by 100. So 0.2. So it is 0.2. Okay. Right, next, a random sample of 100 adults. So a random sample of 100 adults. So a random sample must equal to the n value, that is the sample value is 100. A random sample of 100 adults over 40 years old found 15, okay, 15 who exercise at least twice a week. So 15 people, that is X is equal to 15. Is this evidence of a decline in a participation after age 40? So it stated that, is it the true evidence that it is a decline in a participation of American adults after age 40? So we want to find this situation. So it stated that, is this evidence of a decline? So it stated that, is this true that the participation of American adults after age 40 is decline? So decline. It states that evidence of a decline. So when decline, it must be less than 20% or 0.2, less than. Okay, less than. So what we are going to do in our first step? So in our first step, we are going to state our null and alternative hypothesis. So because this is not referred to the average, so it is referred to the proportion. So HO or null hypothesis is P proportion equal to 0.2. So this one, 0.2. And alternative hypothesis, that is HA, should be P or the proportion less than 0.2. So why the alternative hypothesis stated here is P, the proportion less than 0.2? Because it stated about the evidence of a decline, because it want to know either the proportion, all right, the proportion is 0.2 or less than 0.2. Okay, so is this evidence of a decline participation after age 40? That means less than 0.2. So what is the second step? So in the second step, we are going to test the statistic. So what are the formula to test the statistic for single proportion? So this is the formula to test the test statistic for single proportion. All right. Now, how we are going to get the p hat? Okay, if you remember in our previous lesson, the simple formula for p hat is x divided by n. So now what is the value of x? So x is equal to 15. X is equal to 15 divided by, what is the value of sample? That is n equal to 100. So the n here is 100. So you will get the p hat is equal to 0.15. Okay, so the p hat is 0.15 minus P0. So P0 is the proportion of null hypothesis. That is 0.2. So minus with 0.2. And divide square root of PO, that is null hypothesis of P, 0.2, times by QO. So how to get Q? 1 minus P. So 1 minus 0.2, you will get 0.8. So square root of 0.2 times 0.8, and divide by 100. That is the value of n. Alright, so you need to calculate this, the above value first. Okay, alright, so this is the first step for your calculation. Please try. Okay, please try at home. And 0.15 minus 0.2, you will get negative 0.05. Okay, and then the second step, you are going to get the calculation for 0.2 times 0.8 divided by 100. So this is the second step of calculation. Then you will get the value in 0.2 times 0.8 divided by 100. All right. The third step, when you get the value in the second step, and then you square root the answer. Square root the answer. So when you square root the answer in second step, okay, then you will get the value is 0.04. Okay, get 0.04. So in your next step of calculation, that is the final step. Okay, you will get this one in first step. The above value is negative 0.05. So negative 0.05, and then divide by the value is in the third step. When you square root the answer in second step, then you will get 0.04 divided by 0.04. So the final answer, you will get negative 1.25. Okay, this one, 1.25. So what is the next step? So by using critical value approach, what is the critical value of Z that cuts off exactly alpha is 0.05 in the left tail of the Z distribution? So in these examples, all right, they want you to use the critical value that have been given. The alpha that has been given is 0.05. Okay, the alpha that has been given is 0.05. And it wants you to get the value in the left tail of the Z distribution. So when you draw the graph, okay, when you draw the graph, so the alpha 0.5 that has been given, this one, right? And why it is in the left tail, not in the right tail here, not in here, right tail, the left tail, because the question said that exactly in the left tail of the Z distributions. And if you refer to the questions in the previous slide, all right, it also stated that decline, that is the alpha or the proportion is less than 0.2, so less than, so it must refer to the left tail. So the left tail should be in the left area. So alpha is 0.05, so this is 0.05, the area of 0.05. So what are the Z value that alpha is 0.05? So when you refer to the standard normal table, okay, please try to find it in standard normal table. Okay, then you will get the Z value is negative 1.645. Or actually, when you find the Z value in standard normal table, you will see that it is fall in the Z value that is between negative 1.64 and a negative 1.65. It could be between this value. So if you get the when you refer to the standard normal table, you will see that the value of alpha 0.05 is approaching in either this one of Z value. It can be negative 1.64 or negative 1.65. But we are going to, because this is in between negative 1.64 and negative 1.65, so it must be around negative 1.645. Okay. So in standard normal table, it is, okay, this is the value of Z, isn't it? And this one is the value of the alpha. So the alpha is in between something around here. Okay, this one and this one. This one, the value of alpha that is approaching 0.05. Right, this is negative 1.6. This is 4, and this one is 5. So alpha 0.05 here is in between here. Okay, in between here. So it is negative 1.645. This one, 5. So negative 1.645. Okay, never mind. Please try to see and try to find it in standard normal table. Okay, so you will get the alpha value for 0.05 is negative 1.645. Okay, what is the next steps? So we are going to see either negative 1.645 or that have been given is matched with the test statistic that we get. So the test statistic that we get is negative 1.25. So rejection region. Reject HO if Z is less than negative 1.64. So that means in this rejection area. So if it is in this less than, that means approaching to the left, right? Approaching to the left here. So it must be, the HO must be rejected. So if the test statistic falls in the rejection region, its p-value will be less than alpha 0.05 because the cut-off point for significance contribution is alpha that is less than 0.01 and 0.05. Okay. So in our sample, all right, when we find the test statistic, okay, so we get the Z is equal to negative 1.25, isn't it? Negative 1.25. So negative 125 is not in rejection region. Negative 1.25 may be something around here. Okay, negative 1.25. So is it fall in rejection region or not? So rejection region is must approaching to the left or approaching to the right. the left tail and the right tail. So now it is in this region, in the confidence interval regions. So Z that is less than 1.25 does not fall in the rejection region. So HO is not rejected. So we cannot reject our null hypothesis. So what is the final step, the fifth step that we can conclude from this situation? So we can state that there is not enough evidence to indicate that the P is less than 0.2 for people over 40 years. Okay. Right, let's see for the third example. Is there a difference in the average daily intakes of dairy product for men versus women? Use alpha equal to 0.05. So what is the main key point here? So it's stated about the difference in average. So difference in average must refer difference between two mean or mu. Difference between two mean or two mu. Okay. And then the alpha value that has been given is 0.05. So they give you the value for men and women. So sample size that is n for men is n1 and woman is n2. So what sample mean? So what is the symbol of sample mean? That is X bar. So the X bar for men is X bar 1 and the sample mean for woman is X bar 2. And sample of standard deviation, that is S. So sample of standard deviation for men is S1 or S2. Okay, now in our first step, we need to define our null hypothesis and alternative hypothesis. So null hypothesis is HO, that is mu1 minus mu2 equal to 0 or same. And our alternative hypothesis, that is HA, is mu1 minus mu2 not equal to 0 or different. Then we move to the next step, the test statistic. So what are the formula to test statistic for difference between two means? So this is the formula. Okay. So when you insert all the value, you will get 756 minus 762. Okay. Divide by square root 35 square divide by 50 plus 30 square divide by 50. So how to get negative? So when you calculate, you will get negative 0.92. So how to get negative 0.92? Right. First step, you need to calculate the above value. So 756 minus 762 minus 0, then you will get you will get negative 6. Okay, you'll get negative 6. And the second step is you need to find the value in the below without square root. Okay, so you will get here is 42.5. 42.5. Right, and then the third step, you are going to square root the value of 42.5. You are square root the value of 42.5. That is the third step of calculation. Right, and then in your final step, you will get the above value, that is negative 6. So negative 6 minus square root of 42.5. Okay, square root 42.5. Then you will get the final answer is negative 0.92. Okay, so this is not the end. As usual, we need to find the rejection region. So by using p-value approach, okay, so by using p-value approach, p z greater than 0.92 plus p z less than negative 0.92. So when you refer to the standard normal table for negative 0.92, okay, negative 0.92, when you refer to standard normal table, then you will get the answer is 0.1788. So times by 2, you will get the p-value is 0.3576. So this is when you draw the graph. This is negative 0.92 and 0.92. So the p-value, that is 1 divided by 2 because 2 tail. So you will get 0.1788. Okay, now the p-value is 0.3576. So is it greater than or less than 0.05 and 0.01? So 0.3576 is greater than both 0.01 and 0.05. Okay, the cutoff point for significance value is when p is less than 0.01 and 0.05. Now, we get the p-value is 0.35, that is greater than 0.01 and 0.05. So, since the p-value is greater than alpha 0.05, okay, greater than 0.05 and also 0.01, because we can refer to both significance cutoff point, that is 0.01 and 0.05. So since the p-value is greater than alpha 0.05, that is the p-value is 0.3576. This one. Okay. So since the p-value is greater than alpha 0.05, so the null hypothesis or HO is not rejected. Okay, so 0.35 is around here. Okay, this is around here, 0.35. 0.3576. And if we refer to the this is if we refer to the critical value, and if we refer to p-value, it is greater than 0.01 and 0.05. So HO is not rejected. So what we are going to state in our final step, that is our conclusion. So we can conclude that there is insufficient evidence to indicate that men and women have different average daily intakes. So now let's see the final example. Compare the proportion of male and female college students who said that they had played on a soccer team during their K-12 years using a test of hypothesis. So what are the main key points in these questions? First, is it about compare the proportion. So compare must be between two groups. So compare the proportion, that is P1 minus P2. Okay, so compare the proportion of male and female college student and using a test of hypothesis. Okay, so we must state the null and the alternative hypothesis because it wants you to compare the proportion by using a test of hypothesis. So the two proportion that has been given is youth soccer of male and the youth soccer of female. So the sample size for male, sample size is N. So sample size for male is N1 and sample size for female is N2. So this one is the sample size for male is N1, okay? N1. So the played soccer is the sample. Okay. And the played soccer for female is S2. S1 and S2. So the first step, because we are using a test of hypothesis, so we need to state the null and the alternative hypothesis. So for the null hypothesis, that is HO is proportion 1 minus proportion 2 equal to 0. That is same. So what is the alternative hypothesis? So the alternative hypothesis is HA P1 minus P2 not equal to 0 or different. So the next steps, we are going to test the statistic. But before we are going to test the statistic, because the formula for difference between two proportions have the value of P hat, so we need to find the value of P hat first. So how to get the P hat here? If you remember in our previous lesson, all right, the simple formula for P hat, okay, the simple formula for P hat is S divided by N. S divided by N. This is S divided by N, small n. So X here is equal to the X for male first. Okay, it equal to 65 divided by N. The value of male sample size, that is small n, N1 is 80. So 65 divided by 80. So you will get 0.81. And then you need also to find the P hat 2, that is P hat for female. So P hat 2 is 39 divided by 70. 39 divided by 70. So you will get 0.56. And then you also need to find the overall value for P hat. That is the P1, P hat 1 plus P hat 2. So to get the overall value of P hat is equal x1 plus x2 divided by n1 plus n2. So x1 is referred to the male value, the male mean, it is 65, plus x2 is female x value, that is 39. And then divide by n1, that is sample size of male, plus n2 is sample size for female. So you will get 150. Then the overall P hat is 0.69. Okay, after you get all the value for P hat, then you can start to calculate the second step, that is the test statistic. So this is the formula for the difference between two proportions. Okay. Then when you insert the value, you will get 0.81 minus 0.56 divided by square root 0.96 is the P hat, and 0.31 is the Q hat. How to get Q? 1 minus P hat. So 1 minus 0.69, you will get the Q hat is 0.31. All right, and then times by 1 divided by 80 and plus 1 divided by 70. So how to calculate? So the first step of calculation, you must get the above value, that is 0.81 minus 0.56. Then you will get 0.25. You get 0.25. Then you will get the below value, that is 0.69 times 0.31, and then times with 1 divided by 80 plus 1 divided by 70. So first you will times the value of 0.69 with 0.31. Okay, then you will get the value is 0.2139. Okay, and then you will calculate for 1 divided by 80 plus 1 divided by 1 divided 70. So this one you will get 0.0267. So in the next steps, you will divide the above value 0.25 with the below value, that is 0.21 times 0.0267. All right, then the last steps is 0.25, okay, 0.25 divided by square root of the value that you times between 0.239 and 0.0267. So 0.2139 times 0.0267 then you will get the answer, then you square root. Okay, then you square root the answer of the value of 0.2139 times by 0.0267. Okay, then you will get the answer, the final answer is 3.30. Okay, the first step, you must get the above value, then you get 0.25. And then the second step, you must get the value of 0.69 times 0.31. And then you must get the value of 1 divide 80 plus 1 divide 70, this value. And then when you times this both value, then you get the answer. And then you square root the answer. After you square root the answer, then the final step is you get the above value, that is 0.5 divided by the square root answer. So we'll get 3.30. Okay. All right. Let's say using a p-value approach. So by using a p-value approach, okay, p should be z greater than 3.30 or plus with p z less than negative 3.30. Okay, if you draw the graph, it could be like this. So could be 1, 3, negative 3.30, and this one is 3.30. Okay, so this is the area. So now, when you refer to the standard normal table for the z value of negative 3.30, okay, 3.30, then you will get the answer is 0.0005. Then when you times by 2, you will get 0.001. So the value of 0.005 is in here. Okay. This is alpha equal to 0.0005, or the z value is negative 3.30. So the alpha here is also 0.0005. So when you times by 2, this right tail value of alpha and the left tail value of alpha, then you will get 0.001. So 0.001, is it less than or greater than 0.05 and 0.01? So the p-value, that is 0.001, is less than both p-value of or alpha value of 0.05 and 0.01. So since the p-value is less than alpha 0.01, so we are going to reject the HO. So the p-value is 0.01. That is less than 0.05 or 0.01. So because it is less than, so that must be a significance finding. So When the results have a significant findings, we are going to reject the null hypothesis. So the HO is rejected. So what is the final steps that we are going to conclude? So what are the conclusions that we are going to state here? So we are going to say that there is the evidence to indicate that the rates of participants are different for boys and girls. Okay, so that's all for hypothesis testing or hypothesis test for large sample that is greater than 30, that we are going to use the Z distribution. So in this lesson, we have discussed about how to test the hypothesis or the t-test, right, or the test statistic for large sample size. And because it is referred to large sample size, so we are going to use the Z distributions. So when it refers to Z distribution, we must refer to the standard normal table. So in this step, it is important. First, we need to state the null and the alternative hypothesis. And then the second step, we are going to test the statistic. Either it is the single mean or single proportions or difference between two means or difference between two proportions. And then in the third step, we are going to see or to test the critical value or the p-value. Okay, so in this step, we can choose or we can use both, either by using the critical value approach or by using the p-value approach. And then in our fourth step, we are going to state either our test statistic is fall in the rejection region or non-rejection region. And in our final steps, we are going to conclude if there is the sufficient evidence to support our null hypothesis or otherwise. Okay, so if you have any question, you can ask me. So thank you also for watching this lecture videos. I wish you all the best and thank you.